This is video number 4 for sections 8.6 and 8.7, Variation Problems Examples. So in the last video, we covered some of the basic ideas of variation. Now we'll go ahead and work some of the actual problems. It's generally always a 3-step process. Step 1 is write down the general variation equation. That's the one with the k in it. Step 2, if you want to get anywhere in the problem, you're going to have to figure out what that k is. Once you figure it out, you can fill it in, and then you have what's called the specific variation equation. Step 3, once you have that, you can use the equation to answer whatever question is being asked. Take a look at the first example. This is a very simple, stripped down example. There's no real life context associated with it. It simply says we've got m that varies inversely as the cube of d. If m is 4 when d is 2, figure out what m is when d is 4. There are 3 parts always to these problems. The first part helps you do step 1. This is going to help me to write that general variation equation. Then this next part helps me to do step 2. They give me one complete data set, a d value and an m value. They're doing that for only one reason, and that's to help me figure out what k is. Once I know what k is and I fill it into the equation, I can then answer whatever question I'm being asked. That's step 3. All right, let's run through the steps. M varies inversely as the cube of d. When I read that word inversely, that's the one that has to make me think of this format, y equals k divided by x. In other words, the first variable, the m, is equal to some unknown constant divided by the second variable. Now, in this case, the second one is the cube of d. In other words, d cubed. That's the end of step 1. This is the general variation equation. It's not very useful to me, though. I need to find the specific variation equation, which means I need to figure out k. Well, this is why they've told me this information. They've told me one complete set of data. All I have to do is plug that in, and I can figure out k. M is 4. This is a temporary plug-in idea. When d is 2. Well, if I fill that stuff in, the only unknown left here is k. This is a rational equation that I need to solve. I've got 4 equals k divided by 8. It's a pretty simple rational equation. To clear the fractions, just multiply both sides by 8, and that does it. That gives me a value, a k value of 32. I did all of that so that I could take my general variation equation and now write the specific variation equation. The specific one is the one with the k filled in. K was equal to 32. Now that I have this is the end of step 2, now I can use it to answer anything that they want to ask me. They can ask me 100 questions now. Now this problem only asked me one question, which is, now that you have it, figure out what m is when d is 4. Well, that's just simple plug in. Just replace the d with 4 and work out the math. 4 cubed is 64, and this fraction reduces to 1/2. The final answer to the problem is m equals 1/2. Again, step 1, general equation. Step 2, specific equation, which involves figuring out k. Step 3, use the specific equation to answer your question. Well, let's go down now to part B. Part B is a more full word problem. It's got the real-life scenario in it. But in terms of the math, it's very, very similar to what we just did. This problem talks about current flowing in an electrical circuit, and it says the current varies inversely as the resistance of the circuit. That statement is going to help me do step 1, write my general variation equation. Then it goes on to say, if the current is 25 amps when the resistance is 4 ohms, what is the current when the resistance is 5 ohms? That if statement, that's going to help me do step 2. They only are giving me that so that I can figure out the K. Once I've got the K, I can answer the final question. So let's run through our steps. They didn't give me letters this time. What I would do is I would pick letters that are going to help me remember what these things stand for. So I've got current and resistance. I think I'll use C and R. So the current varies inversely. Varies inversely is the one that's a constant divided by the second variable. What's the second variable? It varies inversely as the resistance, my R. If it had said varies directly, then I would have done C equals K times R. Just go with whichever one is being mentioned. That's the end of step 1. There's my general equation of variation. Step 2, figure out what that K is and fill it in. Well, the only way you're going to do that is to have a complete set of data. They've given it to you. The current is 25 amps when the resistance is 4 ohms. Amps and ohms are just the units of measurement in this case. You don't have to worry about them. Just plug in the numbers. The current is 25 when the resistance is 4. Again, you've got a little equation to solve here, a little rational equation. They'll always be pretty simple equations. Multiply both sides by 4 to clear the fractions, and you end up with K equals 100. That's the specific value of K in this problem, and that helps me to complete step 2, which is to write down the specific variation equation. This is the specific one. This was the general one. Step 3 is now use this specific equation in order to answer the question. The question is, what is the current, the C, when the resistance is 5 ohms? They're just telling me, go to the equation, fill in 5 for the resistance. Do the math. 100 divided by 5 is 20. The current is 20. 20 what? Well, I just need to go and remind myself how current was measured. Current in this problem is measured in amps. So that would be 20 amps. All of the problems, all of the variation problems follow this same pattern. Just make sure when you go to the practice and to the homework that you're starting with the correct general equation. Direct variation, y equals k times the x. Inverse variation, y equals k divided by the x.